In this video series, we've introduced TropSat and provided details on its mission to advance the understanding of physical processes that lead to the formation of mesoscale convective systems in the tropics. We've documented the importance of those systems as building blocks from which larger scale and longer lasting weather and climate patterns emerge. We've unpacked the stages of MCS development and looked at the data types that are used to measure their rapid growth and decay. And finally, we've contrasted the restricted availability of that data given current sources with the spatial, temporal, and by type availability that will result from TropSat. In closing, we'll summarize the key attributes of the TropSat mission and how those will impact both Earth science and society. To review, the TropSat mission observes tropical MCS events at their native evolutionary time and space scales. By employing the simple innovation of a very low inclination orbit, each TropSat swath samples large fractions of important tropical variability. Every 100 minutes, the sampling pattern shifts slightly westward with substantial path overlaps, permitting the temporal resolution of evolving building block processes and organizations. The second innovation planned for TropSat is the ability to measure several key variables in the evolution of those MCS building blocks simultaneously. The building block process includes signals in surface temperature, surface winds, boundary layer and free atmosphere moisture content, cloud top temperatures, and rain. Careful selection of active and passive microwave and infrared detectors will allow TropSat to collect these data continuously, system by system, throughout the global tropics. The sensor systems all have substantial spaceflight heritage. They and the algorithms for processing the data streams they produce have been deployed many times and refined over multiple iterations. This allows for rapid system development and substantially lowers technical risk. Here, a point mentioned in the first video bears repeating. The National Academy of Sciences concluded its latest Earth Science Decadal Survey in December 2017. The summary of that survey lays out objectives in specific scientific domains and from those objectives identifies highest priority observables. The TropSat mission aligns near perfectly with the objectives classified as most important in hydrology, weather, and climate. And the highest priority observations identified are those relating to convection and rainfall, right in the observational sweet spot for TropSat. The scientific benefits of TropSat stem from the frequent multivariate sampling of evolving tropical MCS building block processes. Science and operational goals point to better understanding of the physics driving convective organization at a variety of scales. This improved understanding will lead to more accurate parameterization of convection within numerical models, improving the accuracy of both near-term weather forecasts and predictions of longer-term climate change. The value of this level of coverage doesn't come from detailed measurement of a single day or event. It accumulates over time. TropSat will allow Earth scientists to build up detailed and precise composites of the dynamics and thermodynamics driving all MCS life cycle stages, region by region, season by season. Those multivariate profiles will provide unique insight into what today is a barely resolvable process, potentially even serving as comprehensive training datasets to next-generation machine learning systems. And finally, an ancillary benefit of TropSat is that it will cross paths with swarms of small sats that are very popular new platforms for low-cost, usually univariate, single-channel passive sensors. Because of small size and limited power availability, these are generally new instruments with limited operational history. TropSat would serve as a valuable on-orbit calibrator for those that overlap frequencies with any of the sensors in the TropSat suite. Given the multivariate and frequent revisit properties of TropSat, what additional scientific questions can be addressed versus those accessible with current and near-future systems planned for deployment? It all has to do with resolving the building blocks on their natural space and time scales. As we are able to accomplish that, we can begin to address questions like, how do we predict MCS development? How can we parameterize those developments so that global climate models better represent the convective organization process that's important to the climate signal? Moving up the scale hierarchy, what's the essence of the interaction between clusters of MCS and the eastward propagation of the MJO? Again, if we can observe and deduce the process, we can parameterize and better forecast the evolution. Finally, what are the details of interactions, MCS to MJO, to global signals like ENSO, and regional signals like monsoons, tropical cyclones, and atmospheric rivers? What are the other pathways to these regional and global signals that are captured in the TropSat observations? These are some of the fundamental ocean-atmosphere interaction questions we believe can be addressed with the data streams that TropSat will generate. The value of such advances is difficult to overestimate. The downstream societal effects of the large-scale building blocks are all too familiar. Their impacts are global and in many cases devastating. At one extreme, they include droughts and wind-driven fires. At the other, flooding and debris flows associated with torrential rain. These conditions generate losses to property and life. They cause crop failure, leading to famine and disease. That in turn triggers dislocation as people are forced to abandon areas where climate no longer supports adequate agriculture. Among scientists, decision makers, and emergency managers, there is strong motivation to better understand the origins, development patterns, and statistics of these high-impact weather events, both for near-term forecasting and longer-term planning. TropSat observations would substantially advance the science behind this understanding. In summary, TropSat is a high-value, science-driven mission designed to fill a gap in the understanding of tropical convection and how it influences weather and climate. The science is focused on the processes of convective organization within a hierarchy of scales, from the just resolvable building blocks that are tropical MCS to regional signals like monsoons, tropical cyclones, and atmospheric rivers, all the way up to global events like the El Niño Southern Oscillation. Through the TropSat mission, we can expect to better understand the physics of upscale transfer of energy that accumulates in the tropics and is projected and teleconnected to distant regions of the globe with substantial societal impacts. As observations accrue and processes are better understood, more sophisticated parameterizations of convection can be implemented in both weather forecasting and global climate models. The value of these science goals is underscored by the 2017 Earth Science Decadal Survey from the National Academy of Sciences. The observational goals of TropSat align perfectly with the highest priorities identified for multiple specialties in that report. There are clear societal benefits that would emerge from the scientific and modeling advances TropSat will enable in agriculture, urban planning, and emergency management. Improved predictions for consequential weather events alone would help mitigate global economic costs running into many billions of dollars annually. Because of its instrument heritage and efficient constraints with respect to mass, size, and power, TropSat is low risk and therefore cost-effective. Also, due to its instrument heritage, the precision and multivariate data expected from TropSat can be used to calibrate higher-risk small-sat systems that are projected to come online in the near future. Thank you for watching this video series on TropSat. In it, we have sought to make the mission's case for an audience of concerned citizens who are not atmospheric scientists, spacecraft engineers, or Earth Science Agency managers. We do have more technical, programmatic, and science-oriented presentations available for deeper rounds of consideration as those develop. We invite you to stay tuned to our progress in making the TropSat mission a reality. Don't hesitate to contact us with any questions.